Hello, so this is Chapter 11, Section 1, Part B. It's really the sort of the statistical problem part. Part A was the definitions and terminology. All right, so we've got three problem types here. We're going to construct a categorical frequency distribution. In other words, that's a frequency distribution when data is words or letters. We're going to construct a group frequency distribution. And then this is the case when data is numbers. This is more complicated because first we have to make our group structure, and then after that we do pretty much the same thing as the first one. And then construct a stem and leaf plot. This is a different type of graph or chart, and in this case, data will be numerical as well. All right, so let's do the first one. Construct a categorical frequency distribution. These are typically tables with two columns. First column is the categories. Second column is the frequency. Frequency is just another word, is a more formal or technical term for count. All right, so if we're looking at this one, you see this looks like blood types here, right? And if you look at it for a minute, you realize it just lists all your different categories. There's A type blood, B type blood, AB type blood, and O type blood. And then what we do to make a table is just count how many of each of the is in each category, right? So for the A, we're just going to count them. 1, let's see, 2, 3, 4 A's, up 5 A's, right? There's 5 type A bloods in this sample. Type B, it looks like 2 in the first row, 2 more in the second is 4, 2 more in the third is 6, 1 in the seventh is 7. All right. AB looks like 1 in the first, 1 in the second, that's 2, none in the third, and 1 in the fourth and 1 in the fifth. That gets me up to 4. And then type O, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. And, kind of as a double check, we can add those up and it adds up to 25. And that is how many data values we have over there. All right. That's all there is to that. So if they ask you, if they give you a data that's letters or words, that's what you do. You make a categorical frequency distribution. Now, the next is a group frequency distribution. This is what you do when your data is numbers. Okay, when the data that you're given is numbers. And the part that's a little bit you have to be very careful about is when you define your group. Okay, first what you have to do is we're going to have to figure out our class width, and to do that we're going to need to figure out what the maximum and minimum values are. We'll need the number of classes. They're always going to tell us that, all right? So the class width is the maximum value in the data set minus the minimum divided by the number of classes and then round up. All right, by round up, I mean whatever that turns out to be, go up to the next highest integer. If it turns out to be a perfect integer, if it's 7, round up and the answer is 8. If it's 7.2, round up, the answer is 8. If it's 7.9, round up, the answer's 8. So it's not normal rounding rules. It's always go up to the next whole number. All right, then so each of our classes that we're making with our groups are officially called classes. Each class has a lower class limit and an upper class limit. All right, the lowest lower class limit, all right, is always the minimum data value. It's the lowest data value in the set. Another thing to think about in the class width is the distance from one lower class limit to the next. It's not the distance from a lower class limit to the higher upper class limit. It's the distance from one lower class limit to the next, or from one upper class limit to the next, okay? Once we have all of our classes defined, then the question becomes just like the categorical one, and we just count how many data values are in each class. Okay, so let's try one. In one math class, the data below represent the number of hours each student spends on homework in an average week. Construct a group frequency distribution for the data using 6 classes. So here's all of our numbers here. This is all much easier to do if the data is sorted, all right? So I've already typed this into an Excel spreadsheet. Now, really, all I did is I literally just typed in all the numbers. You can see them running down in a column there, okay? So I come over, after I've typed all the numbers in, I hold down my left mouse button and highlight them. Then come over here to sort and filter, and the first one is sort smallest to largest. Okay, there it is. So our smallest then, our first one is 1. Our largest data value at the end is 18. All right, so now we do our class width equals, all right, so our largest is 18, our smallest is 1, so 18 minus 1. They told us they wanted 6 classes. All right, they're always going to tell us the number of classes. We don't have to figure that out. 2.833, always round up, so that's a 3. Okay, now, quick reminder, if this had turned out to be 3, we always round up to the next whole number, we would have said 4. If this had turned out to be 3.1, we round up to the next whole number, it would have been 4, right? If this had been 7.3, we would have rounded up to the next whole number, it would have been 8. Okay, right? And then, you know, if it's big, if it's almost there, like the one we had, right? We got 2.8, we round up to the next whole number and get 3. So our class width is 3. Now, the first lower class limit is the lowest, is the first value, right, is 1. So I'm going to make our classes. Each class has a lower limit and an upper, right? And the first lower is 1. Now, remember, we're going to make 6 classes, right? And the class width 3 is the distance from one lower limit to the next. So just go up 3 till each time till we have 6. So 4, 7, 10, 13, and 16, right? There's 6 classes. Now then our upper limits, right? So if the lower limit of one class is 1 and then the next one is 4, then the upper limit here's got to be 3, right? Just one lower. Now we can then follow the same rule. We just go up by 3 each time on the uppers. 6, 9, 12, 15, and 18. All right. And now we're almost there. Frequency. So remember, this is just the count in each class. All right. And so what's happening here really, right? So our first class is from 1 to 3. Our second class is from 4 to 6. Third class, 7 to 9, right, etc. We just count the frequency, okay? So come over here. How many data values do we have from 1 to 3? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 data values from 1 to 3, counting the endpoints, right? Awesome. So then from 4 to 6, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You see why being sorted makes this so much easier. If this is not sorted, we'd be bebopping around from one point to the next all the way through all these numbers. Okay, starting at 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. And then from 10 to 12, we have 1, 2, 3, 4, 5, only 6. We got 6. And from 13 to 15, let's see, 1, 2, 3, 4, 5. And then our last group is from 16 to 18. We have 1, 2, 3, 4, 5 of those also. All right, and there's our frequency distribution table, and that's how we do it. All right, it's our group frequency distribution table. Most of the work is getting the classes defined. Each class has a lower limit and an upper limit. So there's all our classes. And then after that, you just count how many in each class, just the way you did for the categorical distribution table. All right, so let's go back and so now the next thing, or the last thing even also that we're going to make, is a stem and leaf plot. And for a stem and leaf plot, okay, so here's what a stem and leaf plot looks like. Um, so it's a table also. Stems on the left, leaves on the right. Okay, so the leaves are usually, so they're the lowest digit in the numbers, right? So most of the time they're whole numbers, and then so the stems, the leaves are the ones digit. They could be decimals where the leaves would then be the smallest decimal place, the tenths digit or maybe the hundredths. So, and to the left then, that's the leaves, to the left, the stems are the biggest number, or the higher digits, however many there are. And then they're supposed to have a key on them, like this one says key, 6/2 means 62. So for the number 62, the stem is 6, the leaf is 2, right? So let's look at the last one. See 7, 6 is a number? Well, that would be 76. Here, like, let's look in the row with a 3 in it. So this, what data values here? Well, there's a 35, a 36, a 36, a 36, right? See, everything connected to the stem of 3 is in the 30s because it's the first digits of 3. Everything connected to a stem of 4 is in the 40s, the first digits of 4. And then you just list the digits in order, right? Looking at 40, looking at with the 4 here, there was a 40, another 40, a 41, a 41, a 42, etc. Okay? So really, the stem and leaf plots, there's nothing to them other than that. They're easier to do if you sort them. So let's look at a question. Draw a stem and leaf plot of the data below. The data are the average annual prices of gasoline in the US from 1980 to 1999. Okay, just like on the group frequency distribution, I copied these in. I just literally type them in one at a time into an Excel sheet. This works much easier if they're sorted. So I'll highlight them all again. Come over here and sort. Okay. Now they're sorted. Okay. And you can see, so the smallest digit is the ones place, right? So the stems are going to be the numbers, any digits that are bigger than 1. So it starts in the 80s, right? The lowest one, the highest one's in the 130s. So 80, so 8, 9. Then for the ones in the hundreds, there's the stem has 2 digits, right? There's the ones in the 110s, the ones in the 112s, and the ones in the 130s. All right. Now, let's draw a little line here. Actually, it's going to be okay. So there's the stem. Let's do the leaves over here. So in the 80s, there's only one. It's 86. In the 90s, there's 2 90s. So that's a 0 and a 0. Okay. Notice I'm separating by spaces. In the hundreds, there's 100. That's a 0. And a 106. So that's a 6. There's 2 111s. So in the 110s, a 111 is a 1 and another 1 and a 2 and 3 and 3, 4, 5, 5, 7, and a 9, right? In this data, that stem has most of them, right? So in the 120, there's a 122, so that's a 2. And then there's 3 123s, so there's 3 3s for 3 123s. And then in the 130s, there's a 131, right? Okay, so what will happen in Connect Math is they'll have boxes for you to put these in, okay? A lot of times they'll give you the stems. If they don't, they have boxes. You put the stems in the left-hand boxes. You put the leaves in the right-hand boxes. Separate your leaves by spaces. Sort them in numerical order. All right? So that is it for this one. I hope you found that helpful.